Hello everyone, welcome to today's video where we're going to be looking at abstraction. So, as far as we need to know, let's get the definition of abstraction out of the way. So, AQA have defined abstraction as the process of removing unnecessary detail from a problem. In the terms of a problem, this means taking what we have and turning it into something simpler to understand. So, we're removing the fine details of the problem. In computer science, we can use abstraction for managing complex problems by stripping it back to the bare basics, to the concise problem solution that we need. A good example of an abstraction is a map. So the example we're going to use is the London Underground map. So this is the very first London Underground map from quite a while ago. So it's drawn against a bird's eye view of London. And in terms of a map of the network, this is very useful. So exam questions might ask you about how well is an abstraction used. So if I get our pen out and do some drawing and writing. Now, the problem we have is we're going to go with a problem that is we want to head eastbound from London Liverpool Street on the Central line. So that's what we want. And in terms of a map of the network, so an exam question might ask you in terms of a map of the network. And I know I've said that a lot, but that's the key phrase we're using here. So as far as London Underground is concerned, this map isn't very good because it's against a bird's eye view of London. So it might not show up on the video, but as you can see, we've got road names here, and these are roads in London. So what we can do to this map is we can abstract it. So the map has been abstracted to something that's in terms of the London Underground instead of London. So it's removed the street names and details of London, but we've still got the shape of it. So in terms of a map, is this useful? Well, yes, it is useful. So for example, we want to go from Liverpool Street eastbound. I know my underground map well, so I know that Liverpool Street is here. And we want to head eastbound. So that's in this direction. So we know what we're doing there. However, this map has the shape of London. So in terms of it being of the London Underground, it's not very useful. So we can abstract it to this, which is your common London Underground map. So now the map's been made more linear, so it's in terms of its own network instead of being in terms of London. So is it more useful for our problem of heading eastbound on the Central line? Well, yes, because I can see Liverpool Street here. And I know that if we want to go eastbound, we've got to go up that way. Now we can abstract it even further. So the map has now been abstracted to look only at the Central line. The problem looks a lot more simpler than it did earlier because we've got Liverpool Street here. And we can head eastbound in that direction. But could it be abstracted any further? The answer is yes. The problem is we want to be heading eastbound, so what we can do is we can get rid of everything westbound. So we can abstract it one more time. The problem focuses heading eastbound on the Central line from Liverpool Street. So we can further abstract this mini-map that you get once you are on the platform, and this is a concise solution to the problem that we have, showing how abstraction works to get the bare basics of what you want, removing all the unnecessary detail. So by now we've learned about the three main concepts of computing. We've learned about decomposition, the breaking down of a problem into a number of subproblems or subprocesses, which may further be subdivided. And we've learned about algorithms, a sequence of steps or instructions that can be followed to solve a problem. So we've got three principles covered: algorithms, decomposition, and abstraction. Now this here is a little problem. So we have a game of Mastermind. Now this is a game where you have four colours and you need to break code. And the code has it's a sequence of 5 different colours of the rainbow, and it'll tell you which colour's in the right position, which isn't in the right position. So, in terms of abstraction, so we can explain the game in simple processes. So, the game works where the user, if we get the pen out, enters a code. So we've abstracted that down. Sorry about the handwriting, writing with a mouse pad is a little bit difficult. So the user enters their code. Then, in this bit here, we check if it's right. And then we move on upwards until right.